Dear students, today we are going to discuss a university question which is based upon bijection or one-to-one correspondence. Bijection or one-to-one correspondence, a function f from a to b is one-to-one or injective if for every xy belongs to a, f of x is equal to f of y, which gives that x is equal to y. So a function is 1, if we can write like this, f of x is equal to f of y. We are making the statement like this, f of x is equal to f of y. From that we have to obtain x is equal to y. Likewise, a function f from a to b is onto or surjective if for every y belongs to b, there exists x belongs to a such that f of x is equal to y. Here in onto condition we have to equate f of x with y. So a function which is both 1 and onto is termed as bijunction or one-to-one correspondence. The question is like this: let f be a function from r minus 3 to r minus 1 defined by f of x is equal to x minus 2 divided by x minus 3. Check whether f is bijective. So our f of x is given as x minus 2 by x minus 3 and we have to prove this f of x is bijective. So for proving f of a function is bijective, we have to prove that f is 1 and f is onto. So the condition for 1 is for every xy belongs to a, f of x is equal to f of y, which implies x is equal to y. A function f from a to b is onto if for every y belongs to b, there x belongs to a, such that we can write in the format f of x is equal to y. Then only if we can write this particular function f of x is equal to x minus 2 by x minus 3 in 1 form as well as onto form, then only we can say that the corresponding function is bijective. So first of all we have to check whether f of x is 1 or not. So here this is for checking f of x is 1 or not. For that what we have to do is f of x is equal to f of y. We have to equate f of x is equal to f of y, and from that we have to prove that x is equal to y. So here we can write f of x is equal to x minus 2 divided by x minus 3. Likewise we can write f of y. F of y is equal to y minus 2 divided by y minus 3. In the for 1 condition we have to assume that f of x is equal to f of y. So we can write like this, f of x is equal to f of y, that is x minus 2 divided by x minus 3 is equal to y minus 2 divided by y minus 3. Then after that I am rearranging the terms, x minus 2 into cross multiplying it. So x minus 2 into y minus 3 equal to y minus 2 into x minus 3. Expanding the both sides, so we obtain a common terms xy and 6 on both sides, so we cancel it. So the remaining term is minus 3x minus 2y equal to minus 3y minus 2x. So again rearranging x terms on left hand side and y terms on the right hand side. On the arrangement, minus 3x plus 2x is equal to minus 3y plus 2y. So it is equal to minus x is equal to minus y, which is equal to x is equal to y. So our assumption is correct. F of x is equal to f of y, which implies x is equal to y. Therefore f of x is 1-to-1. Now what we have to do is we have to check whether this f of x is onto or not. Now we are going to check whether f of x is onto. For that what we have to do is f of x is equal to y. So we have to assume that f of x is equal to y, and we start our assumption like this: x minus 2 by x minus 3 is equal to y. Cross multiplying, so x minus 2 is equal to y into x minus 3. Expanding, x is equal to xy minus 3y plus 2, and from that we group the x terms on left hand side and the other terms on the right hand side. So x minus xy is equal to minus 3y plus 2. So we can write from this particular statement x is equal to 2 minus 3y divided by 1 minus 5. So this is the term which we obtain for x in terms of y. Now what we are going to do is, we are obtaining g of x is equal to, we have to prove this statement that g of x is equal to y. So g of x is equal to x minus 2 by x minus 3, which implies we have to substitute the value of y in the x position, uh, value in terms of y, that is x will be substituted with value 2 minus 3y divided by 1 minus 5 minus 2 divided by the whole divided by 2 minus 2 minus 3y divided by 1 minus y minus 3. And if you are expanding and taking the common terms, by cancelling the common terms from the numerator and denominator, as well as we are expanding the corresponding thing and taking the LCM, we have to obtain it as minus y by minus 1, which is equal to y. So our assumption is, our initial session, the g of x is equal to y, we proved that g of x is equal to y, so we can say that f of x is onto. Since f of x is 1 1 and onto, then we can say that f of x is a bijective function. Thank you.